So today I would like to show you some formulas of life insurance contracts. So we are going to start with the whole life assurance contract. So what is the life insurance contract? So the life insurance contract is an assurance contract which pays the sum assured on the policy order death. So sum assured, let's say S equals to the sum assured. So the expected present value is given by SV kx plus 1. So that means expected present value, which is given by ax, is equal to x equal to 0 to infinity v k plus 1 times k probability of dying. So that is the answer. So you can use this one to find the sum present value or sum assured, or this one is computational. You can use mx over dx is the same as this one. So another one, number 2, we are going to so I'm sorry. So how can you find the variance of this one? So the variance is equal to, so you can say variance is equal to plus ax squared. How can you solve this one? You can look direct to the left table, or if you have given a percentage which is not in the left table, so you can say for this one you can see is equal to ax minus vn npx times plus n is equal to this one. So for this one is equal to ax minus vn npx times ax plus n. This one is equal to this one, and this one is equal to this one. Remember, this one is squared. This one is vn to n. So you can do this one and get in the answer. So we can go to another one, number 2, which is term assurance. So what is a term insurance? Term insurance is a contract to pay sum assured on or after death, provided the death occurred during the specified period. So for this one you can see f is equal to 1 v k plus 1 when kx is less than n or 0 when kx is greater or equal to n. So which is equal to k is equal to 0 to n minus 1. This one doesn't go to infinity. So v k plus 1 k probability of dying. So the value of this one, so summation you can say, summation the present value you can say is equal to x with this one dot is equal to k is equal to 0 v k plus 1 k. So variance is equal to 2ax minus this one squared. Or we can use commutation and we say mx minus mx plus n over dx, or ax minus mx plus n over dx. The both of two, they are the same. So we can go to number 3, the pure endowment assurance. So the pure endowment assurance is a contract that provides some assurance at the end of the fixed term, provided that the policyholder is then alive. So we can see here G is equal to 0, K less than N. When it dies, before reaching that times, for this one will be N Vn, the present value of sum assurance when Kx greater or equal to N, when he or she survives to N years. So we can say G is equal to K is equal to N to infinity Vn P Kx is equal to K. So you can see sum assurance is equal to dot copy that one is equal to 1 Vn and Px. This one is survival, where Npx is equal to Lx plus N over Lx. Or we can use commutation and say dx plus N over dx. So the variance is equal to V2N Npx minus Vn Npx squared. That is the variance of the pure endowment assurance. So we can go to number 3. Number 3 is endowment assurance contract. This one is combination of pure and the term. So this one prevents the sum assurance is payable either on death during the term or survival to the end of the term. So we can say H is equal to F plus G, where H is equal to plus 1, or when he dies before this n years, or when he survives to n years or more. So the formula finding the endowment assurance contract is equal to AX, which is equal to the one for the dying, the term plus pure. So using commutation, you can say this one is equal to first for the term over D plus for the pure, which is equal to mx minus mx plus n plus d dx plus n all over dx. Thank you. But remember, here for the endowment, you can also, the variance can be given as V2N NP, the one for surviving times one for the death. You get the variance direct. So you can see here I'm given something like this one, paid in deferred. This one means is paid in advance. That means is nx over dx. So when you paid in arrears, it will be look like this one, which is given by minus 1, which is the same as when we put this one to this one. So I'm going to say nx over dx minus 1 is equal to that one. So for the assurance, we can say x, that one is given by, is equal to 1 plus I power a half, multiply it by ax. But ax, what is ax? Ax, we can say ax equal to 1 minus d, that one. This one means d is equal to 1 minus v, whereby v is equal to 1 over 1 plus I. So you can see Cx is equal to 1 plus I per half Cx. So still you can say mx equal to 1 plus I per half mx, whereby so that one is equal to paid in advance minus a half. So what about when is that one? And this one means in arrears is given by ax plus that one. So that means when given something like this one, ax which is 1 minus d a dot x, that one. So still you can say ax, that one is equal to 1 minus these are just a formula you should know in your mind. So when we divide this one, we take this one to the other side and then we divide, so we can say it's equal to 1 minus ax dot divided by mortality force, that one. This is a formula you should know in your mind. When we come to the net premium, you can write somewhere. These are the one I've shown you the formulas for the premium. As you know, the premium is income to a life office that comes from the payment made by policyholder. So we are going to the net premium. So you can say net premium. Net premium is the amount of premium required to meet the expected cost of the assurance or and the contract given mortality and interest assumption. So for this one, we should know expected present value of the net premium income is equal to expected present value of the outgo and the benefit. So we are going to say P dot X is this one is the net premium payable and in advance through the duration of the contract for an endowment assurance assured to the life aged X with the term is n years, under which the sum assured is 1. So for this one we can say it's equal to AX over for the immediate annuity. So we are going to say for immediate annuity, so we can say immediate annuity is given by over so still we can have another one. For this one we can say is the net premium payable annually in advance throughout the duration of the contract for the term assurance issued to the life aged X with the term n years, and the sum assured is 1 payable at the end of year of death. So this is the formula. Sorry. This is no. This one should be a premium payable continuously at the death benefit payable at the end of year of the death. That is the explanation of this one. This one is the premium payable continuously at the death benefit payable at the end of year of the death. So that is the formula. So we can have another one. PX, that one, which is the net premium payable annually in advance the duration of the contract for the term assurance issued to a life aged X with the term n years, at the sum assured is 1 payable at the end of year of death. So for this one, the formula is equal to you do the premium always they are paid in advance. That's why we are advanced with this one in advance. So still we have another one like this one. These are just the formulas. This one is the net premium payable annually in advance throughout the duration of the contract for all life assurance issued to a life aged X, under which the sum assured is payable 1 at the end of year of death, which is equal to this one. I think this one is equal to AX over, because they are paid in advance sum of premium. So you can see what is this one. This one looks like someone aged X 72 HT. You can see, but this one is just net premium. So we can define this one as is the net premium payable annually in advance for a maximum of T years. This one T years or until earlier death for whole life assurance issued to the life aged X, under which the sum assured is 1 payable at the end of year of death and where ultimate mortality is assured. So for this one you can see Px is equal to, you can see this one is equal to that one over T, whereby you can say Px is equal to mx over nx for the premium. So for this one, using the commutation, we can see this one is equal to mx minus mx plus n over nx minus nx plus that one. So for the endowment, this one is equal to, we can say this one is equal to let's see, yeah, is equal to, you can see mx minus mx plus n plus dx plus n divided by nx minus nx plus n. Thank you.